Good morning, everyone, and good afternoon, everyone. I would like to welcome you to our today's webinar about the circular economy and its impact on businesses. The webinar will be held by myself and our co-host Tim Vorage, the founder and manager of Growth Garage at Mitsubishi Chemical Advanced Materials. I'm Lisa Weigand, advisor for circular economy at Mitsubishi Chemical Europe, and I welcome you very warmly to our webinar today. A short overview of our agenda. Tim will talk a little bit about our circular economy challenge that we are currently hosting, and I will then give you an overview of circular economy concepts and what we at Mitsubishi Chemical are already doing in the topic of circular economy. And then the floor is open for you and your questions that are very welcome, and we're excited to learn what you're interested in. Tim, please go ahead.
Yeah, thank you, Lisa. It's a privilege to be with you on this virtual stage with an expert like yourselves. As I said, my name is Tim Vorage. I'm the founder manager of the Growth Garage in Mitsubishi Chemical. And we are actually hosting engineering challenges, and we are running at this moment a circular economy challenge. We have received, let's say, many questions during our first webinar when explaining this challenge. First of all, there are indeed two categories. The first category is around recycling technology to speed us up, to do this in a smarter way, to do this more efficient. And the second category is really around parts and products that make use of engineering plastics, but also with a really low carbon footprint. And some of them even, let's say, making use of different circular business models, collecting parts end of life, and also, let's say, sending them back for recycling. So based on this first webinar and also the first exciting submissions that are coming in, we actually received a couple of questions. The first one was around, can you explain more around the circular economy and really make a deep dive in that area? And secondly, how is it linked with different business models? How can it impact really your business? So we thought it would be good to have a second webinar and to ask a true expert in this field. And that's Lisa here with me today. So for everybody that is joining us, enjoy the session. And Lisa, I'll give this back to you.
Thank you, Tim. And as you can see, we have also the first webinar already on YouTube. So if you're interested on looking at that, where we explain the challenge a little bit more, please feel free to do so. Now I would like to talk a little bit about the circular economy, but first of all, we need to start with the linear economy. That is our current economic model. And what does this really mean for businesses and the impact it has on the environment? So to really start at the very beginning, the linear economy is our current economic business model that we are using to produce all the materials and products that we currently have and use in our homes and in the daily life. So we are using raw materials for that are being extracted from our planet. Then they are transformed in a production cycle or several production cycles. They're used for a certain amount of time, sometimes even for not even the whole time that they could have been used. And at the end of their life, they are disposed of, usually by incineration or landfill. And of course, if you look at this, this is not a very smart way of using finite resources that our planet offers us. And we could really, improve on this economic model. And not only is it not a smart way of using our resources, it also, comes with some challenges and issues for businesses. So we will talk about it a bit later on in this webinar, but we see that there are a lot more stricter regulations that will come up in the future and that have already come up regarding raw material use and safety of products and so on. There's also, of course, always a supply risk for businesses when it comes to finite resources and products that use these finite resources and then are just thrown away. Of course, the customer focus is also shifting a lot. We see that really well in the last 1 or 2 years, that customers really focus more on sustainability and green products. And if businesses are not following along, they will lose credibility with their customers and on the market. And of course, the linear economy is the way that we are currently using and producing materials is really also posing a lot of environmental problems. So we have deforestation, ozone acidification, plastic pollution, air pollution, and so on, just because we are not really using our materials and what our planet provides us with in a really smart way. What we can also see at the moment, and what's really interesting, is that there's a real pull from the market towards more sustainability. So we really can see the market trends around this. So of course, climate change is one reason for that, but we can also see that customers become more and more aware of greener alternatives for their products that they want to use. So we see a shift towards zero waste, product as a service, as a business model, the reduce of material use in products, 3D printing, or the trend for monomaterials in packaging, extending the loop, which means that you produce products with a longer lifespan and have products that are safe and sustainable by design, and of course recycling of plastic and other materials. So that's really interesting for us as a company to witness that there's really interest in the market to move towards the direction of more sustainability. And what, of course, is also pushing us into that direction is the EU regulations. So we have in Europe the European Green Deal, and this is really important for all the companies who are producing and selling in Europe, or who are even producing overseas but want to sell their products in Europe. So the European Green Deal will transform the European Union into a modern and resource-efficient and competitive economy. And what's really interesting about it is that it is quite a holistic approach. So it also, wants to really reduce our greenhouse gas emissions by at least 55% by 2030 compared to the 1990 levels. But it also looks on it, the whole economy on a more broader view. So it wants to create healthy and affordable food, fresh air, clean water, healthy soil and biodiversity. So that's the environmental aspect. But also it wants to create future-proof jobs and skills for training, for the transition towards a more circular economy. And the goals of the European Green Deal are very clear. So it says no net emissions of greenhouse gases by 2050. And it wants to decouple the economic growth from the resource use. And also no person and no place left behind, which means there is the social aspect here as well incorporated. And of course, when it comes to legislations, one big part is the European Green Deal, but it is split in many different directives and regulations. And the European Green Deal was introduced already in 2019. And very interestingly, for everyone who's working in the field of circular economy, in 2020, the European Commission adopted the so-called New Circular Economy Action Plan as part of the European Green Deal. And this New Circular Economy Action Plan is introducing legislation when it comes to something like the right to repair or safe and sustainable product design, and all these kinds of things to really move our economy in Europe towards a circular one. And there are many different legislations being applied in the last years. Currently, for example, the Packaging and Packaging Waste Directive is under review, where it will be expected that this becomes even stricter than it is now. And the final goal, of course, then is to be climate neutral in Europe by 2050. And we can see, as you can see here on the timetable, that in the last 1 to 3 years, a lot of new legislations and review of current legislation have come up, and we only expect these to become stricter and stricter, and for businesses to really have to adhere to these ones in the future. So let's finally talk about the circular economy now that we've learned about our linear business model and the background of the market and the legislation. So what exactly is the circular economy? Well, the circular economy is part of a resource efficient and sustainable way of life and management, and encouraging the implementation of the UN's agenda for 2030 for sustainable development and respecting planetary boundaries. So that's the overall definition of it. But what does it really mean? It means it has the 3 pillars that the circular economy is based on. And it means that we want to eliminate waste and pollution. We want to circulate products and materials in our economy. And the 3rd pillar is that we want to regenerate nature. And in order to really reach all of those 3 goals, we must look at our economy as it is at the moment and really transform not only the way how we produce products, but also the way how we do business. So the business models that are currently in place will not be sufficient in a circular economy. We really need to look into transforming these as well, and we really need to not only look at traditional waste management technologies, but on all the phases of the material and product life cycles on a global perspective. So the concept of the circular economy is a really interesting one, as you can see illustrated here on the slide. So we have primary energy and primary raw materials that go into the economy, and we produce materials and products out of that. And usually in the linear economy, as I've already shown you, we have the production, we have the use phase, and then we have the disposal of the product. In the circular economy, we really look at the whole life cycle perspective of every product. So that means we think about every step of how this product is produced, used, and then reused or recycled. And this is a really interesting task for sure, because we start with the raw materials and we really look at the raw materials and think which raw materials would be the best ones to use. So we can have recycled content or bio-based raw materials, and then really look at the processing of those. How can we make interesting materials out of this? How can we have a process in a way that is integrated, that has a really efficient use of the raw materials, but also of energy, that has a really low emissions generated? And then we have a smart material that we have produced. When it comes to the products now, we really also think about the design of the products at this stage already. And in a linear economy, usually, you know, every product has to fulfill certain requirements and quality standards, but very often we do not think about the end of life of this product at the design stage. And in the circular economy, it's the actual opposite. So even already at the design stage, we are thinking about which materials can we use that this product will be recyclable or easily repaired. How can we make it that the product can last for a very long time? And which materials can we use so that the end of life of the product will be taken care of? And of course, we come into the production stage where the final product is assembled. We also think about the logistics on how it's best to transport all the materials and the products in the different life stages and to the end consumer. And of course, the use phase is also very important. So we want to create products that can be last for a really long time, that can be easily repaired, for example, or that can be easily recycled at the end of their life. And in the waste management, or the last step of the product life cycle, we think about, okay, what to do with the products now? How can we recover the materials that are in there? How can we keep them in the economy for the longest amount of time at their highest value? And this is actually really another very interesting part of the circular economy is the need for partnerships. So the big goal of the circular economy is really to keep materials in the loop of the economy at their highest value for the longest time, because this means that we have to use the least resources to really transform the material again and reuse again, or to extract raw materials from the earth again. This is a really do this alone. And we really need networks, and we really need an ecosystem that we are building. And here at Mitsubishi Chemical, we're working very hard on this. And one part of this building of an ecosystem is the Growth Garage and our Circular Economy Challenge that we're hosting at the moment. But I really want to stress this point that it's very important to implement a circular economy to really look for partners and keep all of the materials in the loop for as long as possible. So the chemical industry, how can we play a role in the implementation of circular economy? And I will say that we can play a major role in it, because in the chemical industry, we are the biggest producer of materials and products on a global scale. We have a really big lever in this respect to change the way how materials are produced, how materials are used, how products are produced. And we are really already working on it in a big global scale as well. So I've put down here several different categories that really are kind of trends in the circular economy, and I will talk a little bit about that and what the chemical industry can do in these categories already. So mechanical recycling, that's a technology where you take, for example, waste plastics and you clean them and you shred them and you remelt them and use them again. And this is a really nice technology, but it has its downsides since you can only mechanically recycle certain materials for a specific amount of time. But this is really something that we at the chemical industry are already looking at. We want to design materials that can be recycled for many cycles, and we can have additives and so on that really help us here with the quality of the mechanical recyclate. But of course, we are also looking at ways on how we can chemically recycle, for example, polymers, or even develop new recycling processes of materials for materials that cannot easily be recycled using mechanical recycling. And of course, the knowledge of the chemical industry is very crucial here. We know a lot about process design and material design, and we can, so to speak, reverse engineer and come up, develop new technologies for chemical recycling of difficult to recycle materials. Another topic that the chemical industry is really working on a lot is closing the loop and designing processes where we can really go have the product in a cycle. So at the end of its life, we take it back and we recycle it in whichever way and then create the same product from that again. Extending the loop, I've already talked about that a little bit, is where we really design materials that can be used for a really long time, that are very durable and just are very good to be used for a long time, or or products that can easily be repaired, for example. Design for recyclability is also a very interesting category where we also work on developing materials that can be easily recycled, and especially for materials that are currently challenging to recycle at the moment. And of course, there's always the use of recycled and bio-based content that we are working on, where we can really change the raw materials that we are using at the moment, or that are being used at the moment, and go for alternative and more sustainable materials. Another category is the use of biodegradable and compostable solutions, where we design and produce materials that can be composted in professional composting facilities, so that, you know, they don't end up in the waste streams or in the environment. The product as a service category is really a business case or business model category, where we are looking at alternatives where we don't sell the product per se anymore, but we offer several services. So one very prominent example for this one is, for example, to have light as a service and not sell light bulbs anymore, but to remain the ownership of the light bulb and just sell light as a service, where you then maintain office buildings as the owner of the light service, so to speak, and your customer only pays you for the hours of light that he is using. Safe and sustainable by design is really more about creating products that are safe to use, that don't use hazardous chemicals, that don't create a lot of emissions. And that's also, of course, something where the chemical industry plays a major role at. And here I've illustrated all of the categories that are now shown in blue are the ones where Mitsubishi Chemical is already actively working in. And I will give you some product examples in the next step. But first of all, I would like to say again that we are looking for partners here to become a leader in circular economy and sustainability, to really realize the implementation of a circular economy as part of our Kaiteki philosophy. So here at Mitsubishi Chemical, I already said that we are very much working on implementing the circular economy. Already, we have a circular economy department here in Europe and a counterpart in Tokyo in Japan. And the circular economy department here in Europe is spearheaded by our director for circular economy, Nicole Kambeck. And then, of course, I myself am also part of the team. We also have an LCA expert, Balin Simon, who is bringing a lot of expertise to our team as well. And we are working on a big array of topics together with all of our companies here in Europe. We are advising on new business models and technologies that support the implementation of the circular economy. We really take care of external communication and representation of our company and building a stakeholder network for the implementation of a circular economy. We advise on the newest EU regulations and their impact on our businesses and provide LCA expertise and much more. That's just a short example of topics that we're really working on. So I would like to also give you a short overview of the circular products, processes, and business cases we have here at Mitsubishi Chemical. So if you remember the matrix that I've shown you before, so mechanical recycling, we are already working on that. We have in-house capacity for mechanical recycling of engineering polymers, where we really make use of our production waste and so on, and really reuse that in our process. When it comes to chemical recycling technologies, we are working on a project to implement molecular recycling of PMMA, so that's polymethyl methacrylate, or acrylics, plexiglass, for example, where we really are working on the development of a technology to depolymerize the PMMA back to the monomer MMA in a new technology. And that is a really interesting project here. For closing the loop, we have the in-house recycling centers, or even technology where we can do recycling of carbon fibers, where we can really get back the carbon fiber and reuse in new products that we can create in-house. For extend the loop, we are offering the precision cleaning of semiconductor manufacturing equipment parts. So this is a really nice service that we're offering, where we clean the manufacturing equipment parts for semiconductors, and through this really extend their lifespan by a magnitude of times, because the production or manufacturers of semiconductors can reuse the equipment parts many times and don't have to throw them out after one use. We are also active in the category of design of recyclability, where we have created a polymer that is called G-polymer, which is a very special polymer. So it's often used in packaging materials as a barrier part of this packaging material. And what's really interesting about packaging is that it looks like it's just one material that you use for the packaging, for example, for your food, such as cheese, but actually it's made out of a multitude of different polymers. And because of that, this multi-layer structure cannot easily be recycled. And if you use G-polymer as your barrier material in this multi-layer structure, you can easily recycle the multi-layer structure, because G-polymer can be dissolved in water, and then the multi-layer structure just dissolves into the different monolayers again. And that enables really the recyclability of the multi-layer structure. We are also using a lot of recycled content in our products. I have put one example here. We have polyester films in our portfolio that use 30% recycled content already, which is really nice, and yeah, very good approach to become more sustainable. We also have bio-based content in some of our products. So one of them is, for example, Durabio, where it's a polymer as well that can be used in many different applications, for example, in cars and so on, or on phone screens. And this polymer is really bio-based, 100%. And yeah, it's a really great sustainable alternative to other polymers that are based on fossil fuels. We also have some biodegradable and compostable solutions in our portfolio, which is, for example, bio-PBS, that can be used for the coating of paper cups or other applications, and is really readily compostable. And this means that the paper cup can then just be thrown into the compost or can be put into the organic waste, and it will completely degrade, which is not the case if we use polypropylene coating for paper cups, which is mostly done at the moment. And I've already mentioned our product as a service business case of the cleaning of the semiconductor manufacturing equipment parts. Yes, so this was a really short overview of everything we're doing in terms of circular economy at Mitsubishi Chemical. I'm really happy that you joined the webinar, and Tim and myself will be happy to take your questions.
Yeah, and for everyone, you can leave questions in the Q&A feature of the webinar. So leave them in the chat, but please in the Q&A section. So we're waiting for questions to come in, but I have the first one, Lisa, if you allow me to ask.
Of course, go ahead.
Yeah, you showed various categories of approaches for circular economy, right? Such as mechanical recycling, etc. I was wondering in which of the categories you see the most activities happening. Maybe at Mitsubishi, but probably even more interesting in general in the industry.
That's a really good question. Thank you, Bram. So for the chemical industry, I would say that we see the most activity at the moment for chemical recycling. There's a really big push for this technology. that can then solve a lot of problems when it comes to plastic waste that is really difficult to recycle mechanically. And of course, the chemical industry, as I already mentioned, has a lot of knowledge when it comes to chemical processes and reversing those chemical processes. So they're really working a lot on that topic. And closing the loop is the second most important one, I would say.
It's very interesting. Yeah. I saw a question in the chat about what you, if you know of any carbon fiber recycling companies, and specifically companies based in the United States.
So in the United States, unfortunately, I don't know one, but we have one here in our company portfolio that is actually offering a technology or is doing recycling of carbon fiber. They are currently setting up a new plant with bigger capacity, and they have a technology where you can really recover the carbon fiber at the end of the process. Tim, do you want to also add something here?
Yeah, maybe to add on that, and we have a company in Europe, also in Japan, where we really close the loop in the field of carbon fiber recycling, meaning that we take back composite parts that contain carbon fiber from the industry, whether it is in automotive or in aerospace or in sports goods. We take those back and actually we also bring them further into our materials indeed that go into the market. We strive to have all these kind of services available around the globe, so also in US. So this is probably as far as we can go in sharing any comments around this topic, but for sure more to come.
Nice. Then I saw a question in the Q&A section from Arnold Cadieu. I hope I don't pronounce that too wrongly. Thanks for asking that. It's the question like, what type of fiber reinforced plastic you think have the most potential for value recapture?
Oh, that's a really good question. I think, there's more than one right answer here. Of course, carbon fiber reinforced plastics, because then you can take back the carbon fiber, but also glass reinforced plastics, glass fiber reinforced plastics will certainly play a big role in the future here.
Thanks. Another question is what you're specifically looking for in the partners that you're looking for, that you've been asking for in this presentation.
Oh, that's a really good question. I like it a lot. So of course we are looking for new technologies and innovative products, for example, that can also use our innovative materials. So we're really looking also for partners that have the right or the same mindset as we do. So really push for sustainability, and where that is at the core of their business as well, that have also strong business cases, and really, want to partner with us as well. Yeah. Tim, do you want to add something here?
Yeah, so it's actually building, let's say, the complete ecosystem. So it really goes from those first materials, really along, let's say, the circular value chain. So also about people that are helping us, let's say, improving, let's say, recycling technologies, but also actually using the materials, recollecting them back and sending them back. So in the end, let's say everybody along that value chain, needs to be included. So in principle, we are inviting everybody, let's say, to work with us.
Okay, lots of opportunities there. Then.
Absolutely, yes. Yep.
That's great to hear. More questions pouring in, so I'll pick up the next one from Roberto. He asks, so we see additive manufacturing increasing. So what are your opinions in terms of the circular economy approach for FDM filaments or products, because it's very hard to obtain a reliable recycled material at the moment.
Yeah. It's a topic that we very much recognize. We're actually quite far in that. Quality control is of the absolute importance. So there we have put a lot of attention in that. We do promote this. We do know it's a challenge, but on the other end, we also see that it is possible. So we are introducing already, let's say, the first materials with filaments with a high amount of recycled content in there, which is either, let's say, mechanically recycled or coming from chemical recycling sources. Let's say the FDM technology itself is already a technology with relatively low amount of waste, but even there, it's always good to say to see those products back end of life. And if they are designed in a proper way, then they also can, let's say, survive, let's say, multiple recycle loops without losing too much of their properties.
Nice, yeah. And Tim, if I'm correct, you folks produce a lot of 3D printing filament, right?
Yes, that's indeed correct. And it's also very much linked, let's say, to other business groups where they are using, for example, CNC machining. CNC machining intrinsically creates a bit more of waste, which in the end can also be used then to create 3D printing material again. And even, let's say, runners from injection molding, they also can be used in the end to produce materials then for 3D printing. So with having, let's say, that broad portfolio of technologies on board, we also can make the connections between the different technologies. We actually see that a lot of companies, when they go through the phases of startup, scale up, and becoming more mature, they typically also start with 3D printing and then shift to different production methodologies. But still use 3D printing, let's say, especially in the first part when doing some prototyping, when looking at different designs, etc. So yeah, we play in all the different fields, and we also somehow connect them to make sure that we are not losing material, let's say, in one part of the technology without yeah, getting the opportunity to use it in another one.
Yes, interesting. Great. Okay, more questions. I'm trying to keep up. Let me pick up this one. Question from Alexi, who's joining us from Kiev. So I actually see two questions. The first one, I think, is already kind of answered. The fact that you're working with 3D printing and filaments. But the second one is that they're working on a printer with a hardware as a service business model, and if it makes sense to apply that in the yeah, to make a submission in the product category of this challenge. Tim, maybe you can comment a bit on that.
Yeah, thanks. First of all, thank you for the question, and a lot of support to where you are coming from. About, let's say, your question on participating in the challenge, yes, absolutely, because also these kind of submissions somehow support the acceleration of the circular economy. And we are very much interested, let's say, to team up also with these kind of let's say, requests or submissions. Because, let's say, somebody else might have recycled content to produce filament, which can go along, let's say, with this submission. So it's also about connecting the dots along the value chain. So if you have a submission in this part, for sure we will take a look at it and also see how we can connect the dots. So short answer, yes.
That's great. That's great. Yeah, please submit that, and I'm very much looking forward to more details on what you're working on, Alexi. So a question from Glenn from New York, who is asking about if you are embedding certain chemical mixes in the production so that NIR or other lighting can detect chemical thermoplastic polymer signatures. I hope I'm asking that question correctly, Glenn. Otherwise, just comment in the chat. But does that is that something you can answer, Tim?
I'm not sure if I understand, let's say, the question correctly. Let's say if it is about, let's say, fingerprinting different material streams, this is still a challenge. Yes, there are some technologies available, for example, with light or with density or combinations thereof. We do not yet see a technology that, let's say, that does it all. But for sure, these kind of entries, they are very interesting, because probably we need a package of different technologies to do that separation in the right way. Sorting, let's say, the waste stream is one of the most important things, because we want to make sure that depending on the application, for example, if we would need food approval, that it's also coming, let's say, from the right sources. So is it a challenge in this industry to make this happen? For sure, yes. Any technologies available out there or ideas that would complete, let's say, the package that we already have available are indeed of high interest.
Absolutely, I would agree on that. And sorting is really a challenge, especially if you have a material mix. And when it comes to mechanical recycling or also some other recycling, chemical recycling technologies, you want to have a pure material stream. So yeah, that is certainly something of interest for us.
Nice. Nicholas asks, to what extent Mitsubishi is using bio-based materials to replace fossil-based mass production parts. So yeah, to elaborate on that, how does in this case Mitsubishi is finding ways to mass production of bio-based parts while minimizing trade-offs in other parts of the value chain?
Yeah, that's a really good question that I can maybe answer in a bit of a general way. We are always looking at alternative materials that we can use for our products. So bio-based materials or bio-based content, we have several products on the market already, and we are looking into new products here as well. But we also have to be very careful, because just because we're using bio-based content does not necessarily mean that it's one size fits all solution for all of the problems that we currently have. Because some of the bio-based materials that are out there and are being offered on the market do not necessarily have lower carbon footprint or bring other problems with them. So we are very selective with our products that we replace and that we use bio-based content for, but it's certainly something that is of interest for us and that we are looking into using.
Maybe to indeed add on this, let's say, if, let's say, the source for a bio-based polymer is in competition with the food chain, it's something that, as per definition, we try to avoid. And as also Lisa indicated, it's very important that we make this quantified analysis whether a bio-based polymer is indeed a better solution versus, let's say, either a virgin material or mechanical or chemical recycled. And that quantification, let's say that LCA expertise is something that Lisa and team really brings to the table. So also in the whole circular economy challenge that we have, it's great to have, let's say, this expertise on board in our jury panel, in our expert team, to really support everybody that has a submission, and also make the right decisions, let's say, for the right reasons in a quantified way.
I think
Great.
we have time for one more question, right? And then we're coming to, or
Yeah.
one or two more questions, I would say. Yeah.
Great. Well, then I'll pick up the one that just came in. If you're looking at any like natural fiber reinforced plastic, so I can imagine that's like flex fiber or any of those like natural fibers. What are your thoughts on that?
Yeah, certainly also very interesting technology or a concept. But again, here you really need to take a look at the origin of the fibers, the product. So yeah, it really needs to be looked at from different angles. And but if you're asking to submit to our challenge with a product like that, also feel free to do that.
Yeah, so especially, let's say, in our composite business, natural fibers are indeed being looked at. It's an interesting area. I think there, let's say, that market is still relatively young. It needs to mature, and it also needs to find its way to which combinations with polymers are best, and also what kind of applications are best. So definitely of interest, although, let's say, at the early start.
Clear. Yeah, and it can definitely not hurt to submit something if you're working on that. Yeah, I think we need to start wrapping up. I saw one maybe sort of more general question about 3D printing. Someone asked, we participated in a competition a few years ago when 3D printing was still very novel, but how is it now? Is it now a more everyday-like solution in your methods at Mitsubishi?
You mean the 3D print, the use of 3D printing itself?
Yeah.
Yeah, I would say yes. So it's already, let's say, a mature business for us and also for our customers. So yeah, that's a clear yes. It depends a bit on the industry where that maturity level is. For some industries, it's still a prototyping, or let's say visual prototyping. You see that more and more shifting towards even functional prototyping or mass production. So it highly depends on the specification, but for sure we see 3D printing as something to stay. Yeah.
Great. Then we have to wrap up. Yeah, we're gonna put the recording of the webinar online. We'll also try to like add any answers that we can still add, stuff like to the description of that video. Yeah, please go ahead and submit your IDs as soon as possible, because if you do that before the I think it's Friday, the deadline, then you can get early feedback from experts and have a chance to improve it. And yeah, you can always reach out with questions. The email address of that is on the challenge webpage on revolver.com. Tim, is there anything to add to that?
Just thanks to everyone for joining our webinar today. I hope you learned something about the circular economy and about what we are doing at Mitsubishi Chemical. And please, if you have questions, feel free to reach out. And yeah, have a good day.
Thank you all for participating, and also thank you, Bram, for hosting and supporting us.
Thank you, Bram.
Always a pleasure to work with you.
Absolutely, of course. Thanks to all the participants. Great to have your questions, and very much looking forward to your submissions.